Hello and welcome to Sweeter Start. In today's video, we are going to start with multivariable calculus, and our first topic will be multivariable functions. So let's start with an example. We all know how to calculate the area of a circle, right? And we know that circle is nothing but it's the locus of all points that are at a fixed distance from a fixed point. The fixed point is the center, this is the center, and the fixed distance is the radius. Right? We all know about this. Now, how do we calculate the area of a circle? We know area of a circle is nothing but it's pi times radius squared, right? So if we know the radius of the circle, we can easily calculate the area of the circle, right? Now, if we we can write area. So area of a circle is nothing but a function of radius. As I vary the radius, I can get the area, my area changes, right? So if I am having a circle whose radius is 1, so my area of the circle will be pi times 1 square, which is pi only, right? Similarly, if my radius changes to 2, so if I am having a circle which is having twice the radius of the first circle, it will be pi times 2 squared, which is 4 times pi, right? So you can clearly see that area of a circle is changing as my radius changes. So I can write an area as a function of radius r, function of r. So my area of circle is nothing but a single variable function, which depends only on one variable, and here it is the radius of the circle, right? So this type of functions are called single variable functions, where we are having only one variable and the output of the function depends on only that variable, right? So these are single variable functions. Area of a circle, like we're talking about, uh, perimeter of square, that's 4 times the side, right? So you can think like that about the single variable functions, right? Another general example can be, we write f of x is equals to x square. So it's nothing but a parabola which is passing through the origin. It's nothing but a parabola which is passing through the origin, right? It is symmetric about the origin. Here is my x-axis and this is the y-axis, right? So all these are nothing but the single variable functions which are dependent only on the single variable, like x, like the radius r, right? So now we extend this idea to multivariable functions. Now, using the same idea, we talk about multivariable functions. So multivariable functions are functions which are dependent on more than one variables, like f of x1, x2, dash 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 till xn. So this is a general representation of a multivariable function of n variables, a function that is dependent on n independent variables, where x1, x2 and xn, these all are some independent variables, right? Now let's try to understand the idea of multivariable functions From an example, we know how to calculate volume of a cylinder. This is our cylinder, right? Oh, let's draw it clearly. Right. This is our cylinder. So, a cylinder has a circular base, and that circular base has some radius, and it has some height h. So there are two circular bases, that is the bottom one and the top one, both are having some radius r, let's say, and the height of the cylinder is h. So we know volume of the cylinder can be calculated using the formula, that is pi times the radius square into height. Right? We all know about this formula, that the volume of cylinder is given by pi times the square of the radius into height. Now, just closely observe the formula. We can see pi r square into h. From a previous example, we know that the area of a circle is pi r square. So, I can break this formula as pi r square into h. So, it's the area of the circle, that is the bottom or the top one, we can say, and the height, so area multiplied by the height. Now if I change the radius, I get different bases, right, keeping the height constant. So let's say I'm having some unit circles, and I can draw a cylinder like this for some height h1, and for the same unit circle we can draw a cylinder with height h2, right? So I kept my radius constant and I get different cylinders for the same circular base, right? So the circular base has the same area, only the thing different in these two cylinders is their height, right? And in the same way, I can keep my height constant and vary the radius, so I get a cylinder which is a bigger one or a cylinder which is a thin one, right? So if I vary the radius and keep my height constant, I get a cylinder like this, or a cylinder like this. So they both are having same height h, only the difference between these two cylinders is the difference in their radius of the circular bases. So what do you see from this formula? That varying the radius, I get two different types of cylinders, I get different cylinders keeping height constant, and when I keep the radius constant, I get cylinders of different heights, and when I keep my height constant, I can get then also I get different cylinders having different circular bases, right? So you clearly see the volume is changing. Either I change the radius or I change the height, right? So this type of functions in which are dependent on more than one variables, like here the volume of the cylinder is dependent on the radius as well as the height, and we clearly see from the example the volume of the cylinder changes as I change the radius or height. Here I kept the radius constant and I change the height, so I get two cylinders of having different volumes. One is having a volume pi r square h1 and another is having pi r square h2. Both are having the same radius. Now I keep my height constant and change the radius, so I get two different cylinders One is having a radius r1, another is having a radius r2, right? And they are having the same height h. So I get a cylinder having a volume by r1 square h, and another cylinder, that is this one, having a volume by r2 square h. And clearly from the figure you can see they are having different volumes. So if you pour water in any of the four cylinders, in these two cylinders, they will not occupy the same volume, because both cylinders will not contain the same volume of water, because they are having different volumes, they are having a different radius, right? So using this idea we can clearly define our multivariable functions as a function which is dependent on more than one variable. So here the volume of the cylinder is dependent on radius and height. So volume of a cylinder is a multivariable function, right? So this is the idea about multivariable functions. Functions which are dependent on more than one variables, more than one independent variables like x1, x2 and xn, right? Now we will talk about the domain and ranges through some examples, right? We'll look at some examples of some general functions, and we will see. So the formal definition for a multivariable function can be stated as: a multivariable function is a real valued function where, let's say I'm having my multivariable function as this. So a multivariable function is a real valued function where x1, x2, xn are all independent variables. These all are independent variables, and the values of these variables, the values are real numbers only. It means x1, x2, xn are all real numbers, right? So these are independent real variables, you can say, or the values of these variables, independent variables, are real numbers. So when we input real numbers into this multivariable function, it gives me an output which also is a real number, right? So such a function is called a real valued function, and and the input of this function is called the domain. So x1, x2, xn define a domain D, and the output, let's say the output is equals to W. So the values of W, for different values of D, I'm going to get some output W, and that W is that set, the set of the all possible values of W will be the range, right? So the set of W, set of all possible value W is the range, and the set of all possible, for all possible values of the input for which the function is defined is the domain, right? So let's look at some examples to get a more clear idea about multivariable functions. Let's say I'm having a function f of x comma y comma c equals x square plus y square plus z square. So here I'm having a multivariable function defined in three variables. The three variables are x, y and z, and it is defined as the square root of x square plus y square plus z square, right? So I need three variables, and in the geometric way we can thought of it like I need 3 points in space to define this function, right? So I can try to define its domain and range. So look at this function. The function is defined as square root of x square plus y square and z square. And for every value of x, y and z in the 3D plane, right? This is my 3D plane, this is my x, this is my y, and this is z. So x, y, and z, x, y, and z. So for every point in this 3D plane, my function is defined. I will get some value of f of x, comma y, comma z. So its domain will be entire space, right? For every point in the space, the function is defined, right? It is not getting a value, which it is not giving us an unbounded result. It is not giving infinity, right? So the domain is entire space, and if we talk about its range, right? If we talk about its range, we are talking about a real valued function, and since we are having square root of x square plus y square and plus z square, its range will be 0, closed open interval from 0 to infinity, right? Because we are having a square root, and we stick ourselves only to getting positive values of the square root. So its range is closed open interval 0, infinity, right? Talking about the next example, let's say we're having f of x comma y. It's a multivariable function, two variables, and sine of x, sine of xy, right? So this is another example of multivariable function, and it is given to us as sine of x into y. So its domain for every value of x and y in the two-dimensional plane, for every value in the xy plane, the my multivariable function f of x comma y equals sine of x times y is defined, right? So my domain is entire xy plane, and if I talk about its range, and if I talk about its range. Now we look at the function. It's the sine function. So we know the sine function is bounded uh, between -1 and 1. It can have the lowest possible value, that is -1, and the largest possible value, that is 1, including both -1 and 1. So its range is closed interval -1, 1. Right. So I hope you get the idea about what is a multivariable function, how do we define it, right? And throughout the series, we are going to stick to the definition that multivariable function is a real valued function. We will be dealing in real numbers only. We will not talk about the complex numbers, right? And we in this video we get the idea about what a multivariable function is, how do we define it formally, and we look at some examples. Thank you.